Afternoon. Today, our review about the derivatives is part of the basic calculus. We will start with the how to find the derivative by using the definition of the derivative. Last week, we talked about the limits, and today we will use that limit to find the derivative. This is the formula for finding the derivatives. Okay. Okay, let's continue. Let's have this function, and I want to find the derivative of this function. By the way, the derivative meaning is slope, because the definition of the derivative it's dy over dx. Okay, now let's find the derivative of this one. First, I want to find how much f of x plus a. Okay, in this case, it will be 2. Every x, I will substitute by x plus h. Square minus 16 okay, 16 x plus h plus 35. Now I have f of x and I have f of x plus h. How is substituted in this formula? It will be limit h approaching 0 this one I will put it here. I will use red color. Okay, 2 x plus h squared minus 16 x plus h plus 35. Okay, this is my first part. Okay, minus the f of x, which is this one. It will be 2x squared minus 16 x plus 35. Okay, divided by h. Now let's simplify this one and we will solve it. Okay, and we have limit h approaching 0. We have h down. Okay, the first one, it will be 2. I will open this one. That will be x squared plus 2x h plus x squared. This is the first one. Minus 16 x plus h plus 35. This one is multiplied by negative to be minus 2x squared plus, because this negative is negative, plus 16 x minus 35. Let's simplify it again. Okay. It will be limit. This method, if you long, okay, let's open this one and use the red color here. This one will give me 2x squared plus 4x h. I multiply this one by this 2 plus 2x squared minus 16x minus 16h okay plus 35. Now this one is minus 2x squared plus 16x minus 35 divided by h. Now let's see if we can cancel. Okay, this one, it will be cancelled with this one. And 16x, this one, it will go with this one. 35, it will go with the 35. Okay, I will just make it a few shorter. Okay. Now we will have limit h approaching 0. Remaining here we have 4xh plus 2h squared minus 16h no over h. Okay. It's limit h approach 0. Take h outside. Here the remaining 4x plus 2h minus 16 over h. Okay. Now I will cancel this one with this one. Okay, remaining only this one. I will take the limit of this one. And then as you remember, if you watch the first video, the answer will be 4x plus minus minus 16 because this will be 0. This is the final answer. Now we can say the derivative of this one is equals to 4x minus 16. We refer it like this to the derivative. Sometimes they're using y prime or f prime. Okay, it's all the same. Okay, this method is very long. Okay, but it's required. You should understand how it works. That's why I show you how the step by step how to find it. But there is rules for shortcuts. Okay, and then we can find the derivatives fast than this. Okay, now this is the rule number 1. Rule number 1. If the function is equal to constant, example, I have y equals to 5. What is the derivative of this one, which is dy, refer it to dy to dx. Okay, or you can write it y prime as I said, or f prime. Now, if this function here has no x because here the variable is x, huh? No variable, only constant, the answer is 0. Okay, it's of course because we're talking about slope. Okay, let's say if I want to draw this function, how to draw this function? This is a line. This is straight line, huh? Passing 5, meaning here any value of x, if you get it, it will give you y 5. If it's let's say if this is 1, it will be 5. If it is 2, it's still 5. Okay, the y is always 5. And then we said the derivative is dy of delta y, the slope, delta y over delta x. Delta here is always 0 because 5 minus 5 is 0. And then 0 divided by any number, real number except 0, of course, it will give you 0. But with the condition delta x, it should not be 0, of course. Okay, that's why the derivative here is of the constant 0. If we go back to our first example here, I have here 35 is a constant. You can see here it is 0. It's not appear here. It's not appear. Okay. This is the first rule we have. If it is a constant, it is 0. Okay. Now let's go to the second rule. Second rule said if you have x power n. Okay, let's say x power n. Example. Let's say what I have in the first one was x squared. Okay, I have x squared. If it is y equals 2x squared. Now, if you want to get the derivative, which is y prime, he said you get this 2, this number in here, you put it in the front, and you multiply it by x, and up it will be 2 minus 1. Okay, the answer will be 2x. Okay, if you go back here, okay, you can see the answer is 2x here. It's 2 times, this is the 2 coming from this 2 times 2x. You can see this is the 2x. Let's see this one. Why it is 16. Okay, let's get the other one. Plus y equals to x. Okay, y equals to x. It will be 1 here because if you follow the rules, it will be, this is, here is 1. It will be 1 times x, 1 minus 1. Okay, to give you the derivative, 1 times x power 0. Any variable power 0 is 1. That's why the final answer is 1. Okay. So if you go back here, it is 1. 1 times 16. Now, let's talk about this 2 and 16. What is the property of this one? Okay. Here, the property here says, if you have a function like example, say y equals to 2x squared. Okay. If I have something like that, how I will find the derivative of this one? The derivative of this one, it will be this, something like that. This is the function. This one will be the derivative of this one. This constant, you keep him. This is come from here. Times the derivative of this one. The derivative of this one, I just showed it to you. It will be 2 times x power 2 minus 1. And the answer will be 2 times 2 is 4. And this is x power 1. Okay, you can see it here is this one. Now, and the same, it will be with 16x. Okay, the 16 times 1. Now, the other things also in the property, if you have a function like this, okay, or the function here, the first function here, when you take the derivatives of all this function, okay, you can take the derivative of each part of this one, each term here. In this case, if we follow the rules here, the derivative, you can put dy over dx. I assume you can, it's up to you how to make it, dy over dx, or f prime, or y prime, it's up to you. Okay, with the same meaning in mathematics. This one, it will be 3 times, this one is 2x power 1, because 2 minus 1 is 1. Okay, let's write it. 2 minus 1 plus 2 times the derivative, which is 1, minus 0, because 15 is a constant. Let's fix it. It will be equals to, this is 6 x plus 2. Okay. If you go back here to previous example, this will be 4. 2 times 2 is 4. X minus 16, which is this one.
This one it will work only if we have plus or minus, okay, not multiplication or division. Okay, now let's go to the product, meaning if I have multiply two functions, okay, if you have two functions, you multiply it by each other, okay, the story is different. Okay, this is the rule. The rule said you take the derivative of the first one, you multiply it by the second one, plus the second one times the derivative of here is the first one times the derivative of the second one. Which one here? G is the second. The second times the derivative of the first one plus the first one times it's the same. Okay, you can put this one before this one. The same meaning. Meaning you get the derivative of this one times this one plus derivative of this one times this one. Now let's solve it. Now how we solve this one? This is, be sure you put the prime, huh? Because this is not the function. This is the function. This is the slope, the derivative. Okay, I will follow this one. Okay, the second one. This is the second one as it is, times the derivative of the first one. The derivative of this one is 2x. Okay, plus. Always there's a plus. Now we start with the second one. Now is the first one times the derivative of the second one, which is 6x power 5. Now let's simplify it. This will give me 2x power 7. Okay, this is simple 7. And this one, it will give me 6x, okay, power 7. If you add them together, it will give you 8x power 7. This is very simple. I give it to you, but it's not like this usually. But I give this example because we are only this rules we have yet. Okay. Now, if I make this one, if you multiply them, it is x power 8. The derivative of y equals to x power 8. Okay. You can find the derivative of this one is 8 times x power 8 minus 1 is 7. You can see the same answer. Okay, but it is not like this because there's a lot of things I didn't talk about it. Like example, what about if it is like this one, y equals to let's say x cube times sine x. Okay, that's why this is the f and this is g, and then you need to follow the same rules. Okay. Now let's take this one. Okay. If it is Gaussian is if it is divide. Okay. Let's get something like let's say my y is equals to x squared plus 1 divided by x. Okay, divided by x. Now, if it's easy for me, I will just bring this one up, and then I will follow the product rules. But you can do it like this also here.
Okay, then start with him, which is say, what you will do, you get the derivative of the one up here, which is the derivative of this one is 2x, because it's 2x plus 0. Okay, times g. How much g? G is x. Okay, minus the derivative up, which is the f up is x squared plus 1. Okay, the derivative of the one down is 1. Divide it by g, function g here, which is x squared, because this is only x squared. Okay, and you simply you need to simplify it. You will get y prime equals 2. This is x squared. This one, it will be 2x squared, because this one, minus, okay, this one, when you open it, it will be x squared minus 1. Okay, if you want to more, you simplify that one. This minus this one, you will get y prime equals to x squared. This one will be x squared minus 1. This is the answer. Or you can go deeper, it will be 1 minus 1 over x squared. Or you can write it also 1 minus x negative 2. Okay, so it's the same. Okay, we have to solve it. Okay, this is if it is Gaussian. If it is divide, we follow this rule. Now, let's get the other rule. Okay, the other rule is chain rule. Now, what about if it's my function is like this? Y equals to x squared plus 3x minus 5, example, power 5. Now, we will use here chain rule. Chain rule, he said, when you want to, you take the derivative as it is all, times the derivative inside. Okay, let's see how it works. Now, what is the derivative of this one? Just imagine this one is one variable. This is 5, come from here, times x squared plus 3x minus 5. See, I copy it. This one will be 5 minus 1, it will be 4. Okay, it will be 4. Times the derivative inside. The derivative inside is 2x plus derivative of this one is 3, and the last one is 0. Okay, it's up to you. Up to you. It's okay, but if you want to open this one and you multiply it, it's up to you to simplify it. But this is enough. Okay, this is the chain. This is not apply for this one. Apply for sine, cosine, but you have sine 3x inside 3x, something like that. Okay, let's get something else. Okay. What else we have? So far, so good. Okay. If you have any question about this one, when we meet next week in the class, you can ask that one. It is very important to know the derivatives, because we will use this one in many applications, especially in numerical Newton Raphson method. We need to know the derivatives. Without derivatives, you cannot move. Also, if you talk about simulation, whatever it is, if somebody talks about the derivatives and integration, you should know what is that talking about. If you forget, okay, now I am just reminding you. Now, I will review, summarize thing again. And this method here is by definition. If somebody asks you, find the derivative by using the definition is in place. Limit of h approaching 0 when f of x plus h minus f of x divided by h. This is a long story to but since this is only less than 40 minutes lecture, only to review the things, okay? But if you need more, we will talk another day in more details. That's why I give here is only one example, because anyway, this one will take a few weeks talking about that one in the normal class. And then we take a sample like this one. This is example. And then to apply this one first, we change every x by x plus h. Okay, and this is my f of x plus h. And then I substitute it here. I open it. This is a simple one, huh? Because if this is power 2, 3, 4, 5, really you need to follow rules, and it should be very good in algebra. If you're not good in algebra, it will be a big problem for you. Okay, and this will apply also for sine, cosine, in the other things. Now we will we substitute it here, and then we simplify it. We delete this one constantly, and then we take h outside, okay, and then we cancel to this one with this h. If we cannot cancel it, there is something wrong in your calculation, okay, and then we take the limit. This one is 0 here when you take a limit. Okay. Okay. Let's talk about the summary here. Slowly, Maxwell, because you have a background view, the other system, this one. Let's continue. In the end, I will talk about this. Okay. And then you cancel it, and you get this one. Now, the other one is we talk about the property. If it is between the plus minus, okay, plus minus, you can deal with each term alone, since it is not multiplication. Okay, let's maybe in the end I will give something. You mix, okay, mix, and then we will go much complicated, but I don't want to make it complicated for you, especially the one is maybe the first time you will see, and then after that you will skip from these lectures. Okay, if it is multiplied by constant, you can get the constant side. Now, here we talk about the constant. If we say the function is only a constant, the derivative of the constant is 0. Okay, something like this. And if we have power rule, if you have, this is not power rule. Yeah, power rule is fine. Okay.
if you have variable any power, it will be that n here times x power n minus 1. Okay. Now, I give here examples, and then after that, let's go to the product rule. Product meaning you multiply. If there is a multiplication, okay? If there is a multiplication, you need to follow this rule. The rule, sometimes in the books, you can find it like this one. This is you, huh? Okay, I'll write it here. If you want to find the u v, okay, this is many books using this one. The derivative of uv, but here is fg, some they use, some use uv, and the one I memorize it with uv, I was a student like you, it will be u times dv, okay, plus v du. Okay, the same meaning. Or if you want to make it with this one, it will be f, okay, fg. If you take the derivative, this is, you can find it in the, they call the cheating paper, or the paper you find it in the end of the early textbook, calculus textbook. Okay, and you find that one. This one, it will be f times vg, okay, plus g df. This is more nicer sound than this one, okay, or you use a prime, okay, it's all the same, but most of the books you can find it, he write it like this or like this, okay. Always there is a plus, okay, but when you go to calcium, it is not minus between them, and then always you start with the derivative of the one up, okay. You cannot switch it, but the other one here, you can switch, doesn't matter, because between them is a plus, okay, and you divide it by this function one down. Now the next one is the chain rule. The chain rule is something like that, okay. Now what he will do, you take the derivative of as all, which is 5 outside, you copy this one and times the derivative inside. Now, what about if I have something like this? Okay, let's say I have something like that. Let's say something. Let's write. I have, okay, y equals to x square 3 x plus 5 cube. This is a complicated one, okay? Not very complicated. Now the derivative here, I will follow a product. The first one, this is the first one, times the derivative of this one. I will write the derivative in black color. The derivative of this one, what will be? It will be 3. This is the 3. Let's change the number. That's why it is better to make this one maybe 5. Okay, that's why it will not confuse you. Because 5 here, I will get 6 because there is another 5 here. Okay. Okay. Now it will be 6. This 6 times
the derivative, this one, which is 3x plus 5 power 5, because 6 minus 1 is 5, times the derivative inside. Let's say if this one, let's keep it as it is. This is inside is a 3, correct? 0. Okay, you see, the first one times the derivative of this one plus, okay? Now, plus what? The plus this one, I will write it in red, okay, which is 3x plus 5 power 6 times the derivative of this one, which is x, because 2x. 2 times 2x. Okay? You make this one ahead, or this one like in the formula. He said this is first and this is second, the same. Okay? I prefer the first one times the derivative of the second one, plus the second one times the derivative of the first one. Or if you want opposite, the derivative of the first one, okay, times the second one, plus the first one times the derivative of the second one. Same. After that, you simplify it. Like example here, it will be 18x squared times this one. Then you want to make x outside. It's up to you. This the remaining solution. Okay. Okay. Other things, maybe another time we will talk about the trigo functions like sine, cosine, because now it's already 42 minutes. That's enough for today. Maybe we will make derivatives part 2 before we go to integration. That's why you will learn something much complicated than this one. But please, if you try to watch it again and to make some examples, that's why when I will talk about something a few complicated, you will start. Okay, up to here, what we can say, have a nice day. Bye.